Thank you. Hi, everyone. Can you hear me okay? All right. Everyone doing well? You ready for the AI part? You know you can't avoid it. Okay. So this is new material. Let's see how it goes. I'm not going to sell you anything. I just want to talk about what I learned. And I want to talk about it from the perspective of a system engineer, because that's what I am. See, I'm a bad one because I don't test my systems. Oh no, wait. Oh, I was using the wrong one. Okay. So yeah, I'm going to talk here as a system engineer. I'm also a founder, and I like to sell things, but I'm not selling anything today. So who considers themselves a system engineer? Okay. I would include SRE, platform engineer, in that, keeping things running. So the question I want to try and answer is, why should we care about this AI agent mania that we're in right now? Like, what does it actually matter in engineering terms? And I'm going to start with a baseline. This is the stack, a simplified view of the stack as we know it. The good old days when things were simple. You got a developer using dev tools to make an app for users, right? And then, of course, holding it all together is the systems engineer running the infra, right? So I'm going to say that's been our reality for 10 years. But now, everything's different because we have these incredible brains, right? Those AIs. And it's going to be totally fine, and nothing bad's going to happen ever. We have this under control. So the new stack, with this new AI magic infused, it looks a lot like the old stack. It's basically the same thing, but with LLMs everywhere, right? So you've got the developer now is using a coding agent to produce an agent that users will use. But it's really just dev tools with AI and an app with AI. That's what an agent is, really. It's OK. I'm here to talk about it, so I think it's cool. But just to kind of simplify, that's really what this is, right? It's apps with AI. And of course, we've got systems engineers holding it all together with a lot of GPUs. Sometimes your GPUs, sometimes someone else's GPUs with a big margin. But that's basically the new stack. I didn't want to write the new stack because I feel like it would be infringing. if you're watching this. OK, so that's the situation. Hopefully you're still with me. So really the question is, OK, how does that work exactly? Like if an agent is just the app plus some AI, at an engineering level, what does that mean, right? I mean, obviously we've all used GPT. I'm sure some of you have used the APIs, but really, with my systems engineering hat, I'm always trying to boil things down because these systems get so huge and complicated, especially the real ones. You're only really going to remember very simple primitives, right? So what are the simplest primitives when you boil down all the unnecessary details? How does it get glued together? So again, a baseline. When you're programming, there are primitives, right, that you're building on. And if you've ever programmed, these primitives so naturally that you don't even stop to think about them anymore. But those are the building blocks. Those are the Lego bricks, right? You have a function call. Oh, by the way, who here has programmed, writes code? Just want to know OK. So I know I'm stating the obvious here, but bear with me. It's good to go back to fundamentals. And if you've run larger, complicated systems, you've probably learned that lesson through pain. OK, so function calls. Function A calls function B, gives an argument, gets a return value back, right? A branch, I got those mixed up, branch and loop. OK, I should have said that was on purpose. Like, I'm going to quiz you guys. Right, OK, so loop, you run some code. There's a test condition. Depending on the results, you run this code or that code, right? A branch, same idea. You run the code, and then you keep going until the condition is met, and then you end. Callbacks are a little fancier, but they're actually really everywhere. So that one's it's really obvious if you know it, but if you don't, a function calls another function, and it gives as an argument a function, right? So I'm a function, I receive another function as data, but then I can call it, right? And that's a really cool, powerful pattern that really all of the stuff that we're seeing at the booths outside is built on, really. Okay, so these are the primitives. There are others, but just to give you a sense, that's the frame. We should think in primitives. Now we got 2 new primitives. And that's really the trick. Instead of thinking of it as something completely outside of the realm of software, think of it as still all just software, just with new primitives. So one is chat completion, GPT, hello, and then hello back. Hopefully more interesting than that. So just getting the LLM to generate stuff. Kind of obvious. The reason agents now are sort of entering this new phase of mania is because there's a new primitive that's been perfected that is now working really well, and it used to not. And now you can build all this cool software on it. I call it the agentic loop. You'll hear about tool calls a lot, right? But really the primitive that you get is this agentic loop. So that one's a little more complicated, but it's not actually that complicated. It's really a mix of loops, callbacks, and an LLM. So a function calls an LLM. It gives it callback, so it gives it functions to call, just like a normal callback, right? Except it's giving it to the LLM. Here's a bunch of functions, and then here's a prompt. And then the LLM, just in its crazy digital brain, thinks about the prompt, and then it decides to call functions. And then it decides whether it should stop, and then it keeps looping and calling more functions until it decides that it's done. So again, very weird and different if you look at it from a software programmer's lens, but really that's what it is, right? And just like for those of you who've programmed at the lower levels of the stack, sometimes the hardware comes up with a new crazy set of instructions, and you're scratching your head like, wow, that's a really complicated, fancy instruction. How can I take advantage of that? And then someone says, oh, I know. Well, if I use it this way, my video encoding is going to be 100 times faster or whatever. This is the same thing. It's just a new specialized primitive. But it's really powerful because it can generate, it can just decide, right? Crazy. So you have a brain in your software. That's it. That's the whole, those 2 primitives, that's the whole agentic stack. Then from those primitives, you have the whole process of thousands and millions of developers figuring out how to mix and match those primitives, thinking of different patterns, and then picking the right pattern for the right situation, iterating. But that's basically what's unfolding right now. And then you have the business people on top packaging it and saying, would you want to buy this for $1 million? There you go. That's the AI agent craze in a nutshell. But yeah, it's good to remember what it's all built on from an engineer's perspective. One quick mention, as you navigate those patterns, usually one important consideration is how much, what's the term? Not predictability, but determinism. How much determinism do you want in your agentic workflow versus how much autonomy, right? And then you find the right balance. And that's basically what AI engineers are doing. Yes, you can be an AI engineer also. Okay, but what about systems engineers? How does that help us, right? We're just going to go from being on call for GPUs now instead of CPUs. Can we make our own life better here? Can we make these systems less miserable to run and maintain? That's what's interesting, right? Okay, so I think there's an opportunity here to take this boiled down understanding of the primitives and understanding of how developers are just rushing to build with them and apply that to simplify and reinvent the system layer. Remember the system layer? Remember when the operating system mattered? Like developers actually learned about the system underneath and they called the APIs of that system, right? Not really the situation anymore. We're kind of this weird in between where, of course there's Kubernetes and all this cool infrastructure, but it's different because the application runs on Kubernetes, but it doesn't really call Kubernetes. There are some exceptions, right? But it's really just hardware, super cool scalable hardware. So it's infrastructure, but there's no really replacement for the good old days of I'm a developer, I'm targeting Windows or Red Hat or whatever. But that's actually useful. And I think it's going to become especially useful now because we have all these new primitives and all these new patterns incubating and just sort of growing and growing and growing the stack from the top. So this diagram here represents apps, right? These agents ballooning with their own implementation of these primitives. And it can be in the form of just literally an application developer just implementing it themselves. But now you have a whole ecosystem of frameworks and libraries, right? The AI agent frameworks, like who here has tried at least one agent framework? Okay, there's so many. They're at the application layer. They're language specific. They have these crazy new terms that everyone's kind of figuring out the patterns, right? So this is it's the Cambrian explosion phase. It's normal, it's fun, but it's really a pain in the neck if you're the systems team trying to run it and scale it and streamline it, right? So the way this gets solved, by the way, this is what happened before the golden days of Unix operating systems. This is how it was. And then the primitives sort of moved down. Instead of everyone reinventing their own version of agentic loops and the other primitives, it moves down. And then all these applications can shrink. They're simpler, they're easier to build because they can rely on these existing primitives. That's what the system layer is for, and I think we just kind of forgot because we were in this transition phase. So I think this is very exciting because really this community started with containers and Kubernetes and going from running applications on one machine to many machines, right? That's how it started. It's about distributed systems. But we never really got the application developers to care. They're not programming, again, Kubernetes or the cluster or whatever. They're mostly, we just lifted and shifted. Guilty as charged, because with Docker, that's the only reason people use Docker, because we said, oh, no, you don't have to change your code. No, you just put in a container. Oh, great, okay, so I'll use it. But now, there is a reason to change your code, right? So we should seize that opportunity. I feel necessary to point out that the little guy here is happier. That's the point. Okay, that was obvious. Okay, shouldn't have said. I ruined it. Okay, less fragmentation, less waste, and just kind of to guide your thinking. What does a modern system layer look like now? With this new stack, and just to kind of give a general idea, because of course it's very different than POSIX or Unix, right? APIs are language agnostic because you're making HTTP calls, maybe gRPC calls over HTTP, things like that. You've got these primitives that have been actually incubated here in this community, right? Service discovery, service meshes, of course containers, but also containerized functions, the concept of serverless functions, a whole new paradigm around secrets. That's sort of a given now that you just don't, the secrets are a primitive, right? And we have a good way to handle them. Git is just the uncontested standard for moving artifacts around source code. All these things were not true when Linux was invented, right? And of course now the primitives that we just talked about around LLMs, that should be part of the system stack. So I don't know, I'm getting a little vague here. I really wanted to show demo. I don't know if I'll have a little time, but just think about that. Because this is the community to do it, right? It's still systems engineering. It's still, someone's got to do it. And I think this is the core of the systems engineering community. So this is your job, basically, I guess is what I'm saying. Okay, that's what I have. Do I have extra time? It can be 30 seconds. It's really not. Okay, so the demo is a little disjointed because I promised I wouldn't sell anything. I want to show you our approach to this, and it's not a solution that all of you can use for all of it. So we didn't build the system layer. And what I'm saying is we should all build it together, right? What we've been doing at Dagger is we're focusing on integration, right? As in continuous integration. And that's one piece of the puzzle, one small piece of the puzzle, because focus is good. Oh, I did it again. Okay, going back for a second. Okay, here. right? We're sort of at the intersection of infrastructure and dev tools, right? But those tools need a system layer too, right? So what I'm going to do is show you what's possible, I guess, just kind of a process like a meetup kind of approach. Wait. Okay, I don't know if it's going to work. So is this big enough? Okay. This is a little bit improvised, so maybe not slick. Okay, so Dagger is it's an open source tool, it's an engine, and surprise, we do implement all these primitives, so we try to provide a portable system layer in the way that I described, but only for the use case of integration, again, right? So that kind of skews our approach, but this is just one way to use it. There's an interactive prompt. You can also program it. There's SDKs, blah, blah, blah. Okay, so I want to show you the primitives and how they can plug into the regular system primitives can interact with these new LLM primitives, right? So here I can, for example, I'm going to say, okay, I'm going to create a secret. Oops, I'm going to call it my GitHub token. And it's like a bash-like syntax. I'm not going to. If you're interested in the details of how this actually works, come see me. I would love to tell you more. This is more to stimulate your thinking of what's possible. So I was just, hold on. I'm going to get my secret from 1Password. Let's see. Where is it? This would be a lame place to, oh, it keeps going. Perfect. There it is. Okay, so I'm going to copy the reference of this secret. Okay, so I'm referencing the secret because there's an API that can integrate with secret vaults natively, because that's what a modern system layer should do, right? And then I'm going to build a container. Let's call it base container. Is this readable? Yeah. This is bash syntax. I personally like that, so I'm going to say, okay, just Alpine. Okay, now I'm going to switch to this little prompt mode, and now I have native integration with an LLM. Here it's GPT-4.1 because I'm cheap. But this is all, again, native integration, and then I can prompt it. But the way it's set up is all these objects in the Dagger API, the secret, the container, they have functions attached to them that you can call in a language agnostic way. And I'm giving them to the LLM as callbacks. And then I'm letting it decide. So for example, I can say, hey, I gave you a base container and a secret. Do you see them? Oh, 1Password. Okay, so you can see a trace of the messages and function calls. So it's okay, yeah, I see it. You gave me this, you gave me that. Cool. Install everything on the container to interact with GitHub. Then use the token to, I don't know, list my PRs. It doesn't really matter what I'm trying to do. Okay, so you can see it's trying to execute. So this is the loop. This is an agentic loop before your eyes. Let me try and see the trace here. By the way, using OpenTelemetry, I heard a shout out to that earlier. So this is all, this whole stack is what we've built here in the CNCF community with just 2 new primitives. That's it. That's the point, right? Okay, it's still going. Okay, see that you can see a trace of my exchange here. Hey, please do this. Absolutely, I will do it, blah, blah, blah. You can see now it's calling these callbacks. So here it's calling exec, and it tried to call apt-get. It failed. It got an error. And now it's trying APK update. So this is a perfect example, right? An agentic loop. Call a function, get a result. Oh no, let me try and do something else. And okay, let's see. See, it's executing the GHCLI. It mounted my token as a secret variable. Oh, the base container you provide is Alpine Linux. I have successfully installed Git, blah, blah, blah. However, oh, it's the wrong token. OK, well, I gave it the wrong token. I'm going to leave it at that. But of course, you wouldn't run this in production. But the point is, with just a few primitives that you already know, plus a few new ones, and a way to compose them, this is agentic behavior. Like, this is the same stuff that all these crazy AI engineers are building at the application level, except I'm tinkering with it and I'm scripting it at the system level the way I would write a shell script on a Linux server, right? So that's the feel I'm trying to give you. This doesn't have to be only an application level thing where the devs have all the fun, and at the system level, we're just running GPUs, right? It's much more than that. And I'll just leave it at that, I guess. So, yeah. Thank you all for listening and watching, and come see me if you're interested.
Thank you, Solomon.